So let's take a look at a certain sequence. My numbers that I'm all adding up are a divided by 10 to the power n minus 1. So first I'll have a, and then I will have a divided by 10, and then I will have a divided by 100, and so on. And I actually have a particular value of a in mind for this, but for right now, I'll just leave that as a constant to be specified later. So this is definitely a geometric series. My a value is just the a here. Whatever that's going to be, I'll tell you in a minute. And my r is going to be 1/10. So if you prefer, we can rewrite the equation to make that a little bit more obvious, where my constant, where my common ratio in this limit is and where my a is, just using some simple algebra for fractions. Oh, let me put that exponent up on top. It's too small to be ahead on. There we go. So my partial sums, I need to calculate, if I wasn't going to use my geometric series formula, I would need to calculate what is my Sn. This is the summation where I start at number 1 and I end at n. So here I've got to use, in my notation here, I am using I as my dummy variable, the same way as we use dummy variables for calculating integrals up to t and stuff like that. So my partial sum is partial sum of a times 1/10 to the power n minus 1. And just like I was saying in the previous video clip, this will always be equal to a times 1 minus 1/10 to the power n divided by 1/10. And so in the limit, right, I can take the limit of these terms, limit of the SNs, n goes to infinity. The only n that shows up in the formula for my partial sums is right here. So I know when I take this limit, I will get a times 1 minus 0 is the limit of 1/10 to the power n, as n goes to infinity is 0. And I will divide by 9. So this equals a. Let me do that in text. There we are. Divided by 9. Okay. Now, I could have made this calculation from the very start using the geometric series formula, and that really is the more practical way to do this. You just say, yes, this is a geometric series. I know the formula for geometric series. The formula for geometric series says I take my initial value, a, and I divide by 1 minus, excuse me. I wrote the correct thing later on, but I didn't write it here. This, of course, on my denominator should be 1 minus 1/10. Sorry about that. So let me do this very correctly.